So let's do the short version of this first. Define, I don't call it quiz, something like that. First of all, what's a predicate? Do you remember that part of it? I specifically used the word predicate to make sure you understood what that is. What is a predicate? Go ahead.
It's something that checks the truth value and returns a boolean.
Okay, so takes one parameter and returns true or false. So normal function takes one parameter, returns true or false. So define quiz to be a lambda. This guy's going to take in a list, and we want to return greater than or equal to length LST5.
Have we ever used length before?
I think we have.
I remember this.
Yeah. But, I mean, you could have written your own version of that, right? So, I mean, we could have gone and we could have said, well, we don't know if length is in the language. So then we could have said define length. We'll see if it lets us name it this. It might not let us name it this. And this guy will be a lambda that's going to take in a list. And for us, we need to have it take in a count. Because we need to count up. Actually, we don't even need it to take an account. We can just do math with it. So this guy will take in a list like this. And we're going to ask the question, if null list boil down to 0, this is our old pattern. Otherwise, plus 1 length cooter of our list. And that'll boil down to the number of elements that are in the list. So you could have written it yourself this way if you wanted to. Make sense? So this guy will return, it's a predicate, takes one parameter, returns true if the number of elements in this guy is greater than or equal to 5. Maybe some other ways you could have written maybe a helper that took in a counter or something like that, and you started keeping track of the count as you went through, and as soon as you hit 5, you just return true. Otherwise, if you never hit 5, you would, when you write out a stuff to count, you return false. That would have gotten the job done too. So lots of different ways you could have pulled it off. All right, questions about that? All right, so let's look at the homework. So we are creating, do we actually create block expression for the homework? What was the homework assignment? Have our entire, we're preparing for block expression, right? So have our entire apply program or apply expression in our case return a to list, right? Of the value plus the environment or the scope stack. All right. And we started that, didn't we? Okay, yeah. So our solution here was create a list around what's currently there and then pass around the resulting E and B. And this is going to work for all of them because at this point right now, we don't have the ability to expand our scope as part of our language. That's probably going to be something we're going to add as a define function. We'll do that today. All right, so we'll start up here. So if we're dealing with a const expression, we're going to return the list of that guy with the unchanged environment. And we decide our environment comes second, right? Bool expression, the list containing that guy and our unchanged environment. Diff expression, the list containing our result that we have here. Now, this guy could get a little sketch because we are calling apply expression again on this environment. And that potentially could have a shift. But right now, let's leave it alone because we haven't decided how environments can change yet. All right, so we'll create a list out of the result there along with our resulting environment. For our increment expression, we'll create a list with our result and the resulting environment. Decrement, same thing. Repeat, same thing. Or, well, I'm debating whether I want to actually toss this to a helper function called like a wrap or something like that. I don't think so because the way we might have to change our environment. So we'll just keep going this way. That. Now, do you remember back we had a homework assignment? I think it was a 3-star problem that gave you a hint of something like this, where it had you pass things around as 2 lists. Kind of remember that one? That was kind of preparing us for our environment that's like this. There's so many things. I want to kick this down. Guess that didn't necessarily help us very much, did it?
I have a question about with the lets. I wasn't sure whether or not you could put a let inside of a list. And so I put the list outside of the or instead.
What, like here?
Yeah, instead of doing it that way, I kicked the list down and put it outside of the or. And then EMB.
Okay. Well, this should work fine. I mean, because ultimately, everything that I have highlighted there will boil down to a value.
Okay.
So we're just asking you to resolve that expression.
Yeah.
Right? So this is going to boil down to a single value.
Mm-hmm.
Just our means to get to that value involves a let.
Mm-hmm.
Oh, we still have our... So actually, we do have a way of expanding. Let's leave this guy off for right now. We'll come back and we can wrap it the exact same way. That's what I would have expected on the homework, but we're using our old environment type here. So we would actually fail on our let expression. So this is our first way we can expand an environment or expand a scope stack, but it's only temporary, right? It's only so long as we have it for our internal piece here. So let's leave this guy untouched just for a moment. And then we already did it for our var expression. So here's our list. V. All right, and that should be the rest of the stuff. Okay, now just as a reminder here, let's go back up to our scope stuff we wrote last time. So we have all these constructors and things like that. Do we have the ability to expand a scope? So this adds a scope. Well, this adds to a scope. We don't have the ability to add a brand new scope to a scope stack at this point. Does it look like we have that? Get first scope, get rest scope, first pair. Well, we can create an empty scope, and then we can add to that scope. So we can add to the scope the empty scope of var name var val. But we ultimately need to get this scope onto a scope stack. So we're going to need that ability moving forward. Yeah, we added them to our own scope stack, so we're going to need a constructor for that. So if we come down here to our, let's just look at our let guy here that we left blank for right now. So what does a let expression do? It's going to apply, this is the expression part of that. That's the body of our let, okay? And we're going to be applying that in this extended environment. Okay, so right now we have this scope stack called env. That's what's actually passed here, right? This is our old way of handling environments. We need to upgrade this dude. All right, so what were we doing? We were extending our environment with this variable name. That's the name of our variable. And then this value. Right, so we do have a way to add that to a scope, correct? So let me just kick this, we'll do it like above this. So we're gonna go ahead, we're gonna say add scope, and we're starting a brand new scope here. That is the scope that's associated with our let. So this is gonna be the empty, did I call it empty scope like that, or underscore? Empty, not even underscore, empty dash, empty dash scope. So we like to stay consistent around here. All right, so we're going to add to the scope, empty scope will be our base scope, and then we're gonna add the var name, var val that we have. I'm lost. The language is getting unwieldy.
Yeah, well, it's kind of condensed somehow at some point.
No.
It's just gonna get worse.
Yeah, this is way, way, way shorter than this would be if we wrote it in like Java or something. Oh my gosh, Java would be just, I mean, if we used a different language other than Scheme. This is condensed. We just have a whole lot of parentheses and stuff. All right, so we're going to add to the empty scope a new var name, var val pair. That's the var name. This is the var val. I'm going to kick this down. All right, so that will produce for us a new scope. But we really need to get this scope loaded into our scope stack. So env, our current guy, is a scope stack, correct? And we need to now add a scope to the front of that scope stack so we have a more local scope. So we need to have the ability to do that. Now notice here, what does the scope stack look like? We have one scope. Let's see, this guy only actually has one scope in it. But this would be one scope. And then in this case, we have a brand new scope that we just created here with this add scope. We'd want to insert it before this guy, modifying our scope stack. Make sense? All right, so let's go ahead and give us a constructor for doing that. That way we can, let's see. I need this guy to be in some sort of usable format. So we're going to apply this expression on. So this is the expression we're applying. Here's the environment. We're going to call this almost the environment in which we're applying it. It's the scope, but not the scope stack. So we'll finish that guy there, finish that. Then we should be able to.
Can you just call add scope on the scope stack?
Add scope only works with scopes.
We were using add scope earlier though. Maybe we go down to create a scope stack.
One second. We'll look at it. All right, that finishes there. No, we did our scope. We move it down here to the bottom.
See, add scope. So your global scope is.
Yeah, this is a scope, not a scope stack. So this is my global scope, which is an add scope onto an add scope of the empty scopes. We added A5 and a C7. That's this dude here. So that's what created that. Just what I have highlighted.
Okay. Yeah.
Right, and then to put it into our scope stack, we did this.
Yeah, we just faked it. Okay.
That's it. We faked it. So now we need a constructor for that.
Sorry.
No. I mean, that's the right question to ask because we have created the monster before. We just did it manually. So now we need to give ourselves a constructor for it. So let's throw the constructor up top. Actually, we're going to. We might as well rewrite it anyways. I need to look at what I called it. I'm just going to keep scrolling back and forth just over and over again. There, I need that guy because I'm going to question in a second how I wrote it. All right, so this gets the first scope from our scope stack. So we can work with scope stacks at this point. We just can't create a scope stack. I think if we create a constructor for a scope stack, it's going to require us passing it at least one scope. I think we asked that question last time, whether there is such a thing as a scope stack that contains 0 scopes, and I think the answer is no, right? So we can go ahead and say define create scope stack, and this guy is a lambda that will take in that default scope. Maybe we even call it the global scope. Like that. And what are we going to do with it? We're going to create a list containing scope stack and containing our global scope. Like that. That will create a scope stack. So we can use that. Just get the name of it here. So instead of what we've done here, we can say define scope stack. Actually, let's do them both. We'll call this scope stack 2. Will be create scope stack, passing it that global scope, and then we'll go ahead and we'll print out scope stack 2 here as well. And I'm just not going to call apply program yet. So we should see identical scope stacks next to each other. All right, so we are properly constructing a default scope stack. Looks good there. All right, so now we need to create the, what do we want to call it? Add scope? Add scope to scope stack, expand scope stack, extend scope stack. Cat dog scope stack. What do you want to call it? Extend scope stack. All right, so we'll call it extend scope stack, which should add a new scope to the front of the scope stack. So we'll have to create a list containing the car of the scope stack, as well as the new scope. Actually, we need to cons the new scope onto the cooter of our scope stack, because the cooter of our scope stack is going to be that stuff inside of a list, and we want to cons the new scope onto that. That guy right there is a list of scopes, even though right now he only has one scope in that list of scopes. So we'll cons the new scope onto that, and then create a list that has scope stack as the first element on front of that. So define extend scope stack to be a lambda that's going to take a scope and a scope stack, and we're going to create a list out of scope stack, and the second element of that list is going to be the cons of scope onto the cooter of scope stack, which should create a new list of scopes. And is that how we implemented our scope stack? This is a list this is a single scope. So we actually have this as a flat thing. This is not a list of. So if I cons scope onto this list containing scope stacks, this is going to produce for me a list containing scope stacks. So I actually want to cons that onto that. Otherwise, I'll have a list of scope stacks as opposed to the word scope stack followed by a scope, a scope, a scope, a scope. I don't want those guys to be inside of a list. I want them to be flat. I think we made that decision. That seems to be the direction we went. All right, so with extend scope stack now, I should be able to create a second scope and then extend my original scope stack with that second scope, display it, and it should show me a correctly formatted scope stack. All right, so we're gonna call this guy scope stack. We're gonna dump this. We already have our second scope, so I'm going to we'll go ahead and introduce it. Okay, so what we know how to do right now is if I want to create the scope stack, I'm going to have to do this create empty scope stack. Then I would have to meld onto that extend scope stack with scope 2 onto the create empty scope stack with this guy, and that'll be my scope stack. So kind of have to nest them, right? So let's just run this real quick and we'll see the. So there's my scope stack. Here's the most local scope. And here's the more global scope. So looks like it did what it was supposed to do. Now, what would be nice is if, especially since we're starting to move down this path towards a block expression, which is going to require us to kind of handle things linearly, and we don't have the kind of the tools to do that yet, right? And I'm actually kind of questioning if you're going to be able to handle this next function from a laughter perspective, because it's going to be one of those that's kind of fun to say. All right, so what we're going to do is we're going to go ahead and we're going to create our scope stack like we did originally. All right, so we're back to our original scope stack, just the one scope. Now I want this guy. So now I'm going to extend scope stack. Which scope stack am I extending? I'm extending it with scope 2. Which scope stack am I extending? Scope stack. So we know that guy's going to boil down to my now expanded scope, right? So this was our, yeah, here's my original, I have them in the backwards order. This is the original scope stack, and this is my expanded one. But this guy, unfortunately, boiled down to that. I have not stored it anywhere. Really, what do I want to do? I want my variable scope stack to be equal to this new and expanded version of himself. Okay. So I'm going to print out scope stack here first. That'll show us the original. Then we need to be able to update scope stack with this new version of itself. All right, so it says scope stack. This name was defined previously. So you can't redefine it, just like in Java, right? If I say int a equals 5, I can't then 2 lines later say int a equals 7. I would say a equals 7. So I need the equivalent of that in Scheme. Pronounce set bang. Set bang is how we set a variable to a new value. So it worked. There's my original scope stack. Notice that the set bang boiled down to void. That was the result of it. And then I'll print out scope stack again, and we'll see that scope stack has now been expanded. So there's my now expanded scope stack. All right, that makes sense? Okay, so this will allow us to expand a variable within our environment, I guess, or within our language. So we have this new tool. We have to decide how we're going to use this tool. Let me make sure that we have fully updated this guy. So right now we have this guy as add scope. So what I need to do is I need to extend my scope stack. So I'm going to extend my scope stack with this new scope. So that's the new scope that I'm extending it with in this old scope stack. That's the order extend to. Yep. So extend takes the scope we're extending it with first, and then the scope stack we're extending. So we're going to extend a scope stack with this brand new scope, that guy. And which scope stack are we expanding? We're extending the old scope stack, which we call the ENV in here. And we'll apply expression in that. We need one more closing parenthesis to end our extend scope stack. All right, so now this let expression, all this stuff in here, this apply expression that's happening within this extended scope, that's a temporary extended scope, right? As soon as the let is done, is that new scope that was associated with it dead? We want that to go away, don't we? Just like in Java, when a function ends, the scope that was associated with that function goes away. So we don't want to permanently change our ENV here. It's a temporary change to our ENV. Okay? But Does our language need kind of the ability for an environment to become, I guess, become modified permanently? Should I be able to change the value of, let's say I have 3 different scopes in my environment. I want to change the value of the most global version of A. Let's just say I only have one A. Let's see, do I have there's a B, there's a C. Okay, so let's say I want to change the value of, let's say my scope stack looks like this. And I want to change the value of either A or C, it doesn't matter. So we'll change the value of A. I want to change it to 7. But my scope stack currently looks like this. I need to be able to, when I try to change the value of a variable, I need to search through my scope stack, determine the scope, the most local scope where that variable exists, and then modify that variable in that scope, ultimately producing a scope stack that is the old scope stack with that one variable changed in its specific scope. Scope, scope, scope. Double scope. All right, so how do we pull that off? Now, one thing I could do is I can create this mysterious global environment that just kind of sits out here outside of my apply expression. It's like my starting point. So similar to what we've done here, where we've defined this global scope. But then when we call apply program, we pass that scope stack in. So rather than passing the scope stack in, we can just rely on that guy being this kind of globally available to us. So instead of passing the scope stack around everywhere we go, we have this guy that's just always up there that I can always get. Is that convenient? What's the problem with that, though? What can't I accomplish if I have one global scope that I can manipulate, but I'm not passing scopes around or scope stacks around? This would be a pretty good example right here. What am I trying to do right here? So right there, I'm trying to execute some code in a very temporary scope that might utilize the more global scope, depending on what that code's doing, right? But quite possibly, I have a local scope that has this, we would presume that the reason you've created a let expression is that you intend to use this variable name. Correct? If you're going to create a let and have A equals 3, you're probably going to want to use that local version of A. Otherwise, you were just showing off or something like that. All right. So, but we want that local copy of A equals 3 to only exist temporarily. As soon as this guy's done, we want the scope stack to go back to its previous incarnation, right? Especially as we think forward to our block expression, where we have expression after expression after expression after expression. If we have a let right here, and it lives and dies up here, and then we get to our next line here, we don't want that scope stack that was created for that let to still be available to us, correct? We want the old scope stack, because that was just a temporary little deviation from it when we were dealing with the let. So having that global thing, now we're playing this game. It's like, okay, I'm gonna change this global thing, but as soon as that let's done, he has to go back and undo all of his changes. That make sense? Is it possible? Probably. You could probably, but it might take a lot of bookkeeping in order to make that work. So passing around our environment, the environment in which we want to execute this this expression is handy. That allows us to execute different things inside of different scopes without having any sort of permanent damage that we've done. But now at the same time, if we want to, let's just take the very next step. I want to add the ability to create a variable in my language. If we have if we think ahead and we have this block expression, I want to be able to define A equals 3, right? Or let's pick a new variable. Define Z is equal to 3, something that's not currently in our example scope here. And I want that to be added to my most local scope. I'm not generating a new scope. I'm just expanding my most local scope. with this new variable. We create new scopes with a let, right? In this case, I'm just saying, look, I want a new variable. I want it to be called z, just like you're in a Java program. We say it z is equal to 3. That's going to just tack on that variable value pair to the most local scope. So I want to be able to add that to my most local scope and then have that have an impact on things that happen after that, right? So if we're going down a block structure, and let's just write a couple of examples here. Let's say that my block structure, I start off in, let's say I have a define A is, or what's that, Z is 3, and then we want to do a plus plus Z, something like that. And that's in our block, right? That this guy's inside of our block structure. So, this might be a block that looks like this and ends like that, or something like that. Okay? So this guy happens first, then this guy happens. This guy needs to happen in terms of the scope, the modified scope stack that resulted from this guy. Right? So when I execute, I can't go through and do these guys at the same time. I need to have them happening sequentially, just like we do in Java. When you look at a Java program, you do line 1, line 2, line 3, line 4, right? So I need this guy to occur and modify our environment. Modify, in our case, our scope stack. But I don't want to change this global scope stack, because if I change a global scope stack, then I'm always assuming that I'm executing every expression out of that global stack, instead of having these special cases where I actually need to apply an expression within this particular version of the scope stack. So I have to always have the ability to pass around my scope stack. Now we can create some rules and say, well, sometimes I want to use the global one, sometimes I want to use the local one. We can say that. But wouldn't it be more consistent for us to say that we always use the environment that was handed to us, no matter what? So now we have to have the ability to modify that environment so that when I go and I'm processing a block expression, this guy occurs. What's this guy going to give me? He's going to give me the result of that expression. What's the result of that expression in our new apply expression that we did for our homework assignment? Or what's a reasonable version of that? So it's probably, my scope stack currently looks like this, right? So it's going to be a list containing 2 elements, the solution and then the scope stack. What's the solution of a define Z3? What do we want that to boil down to? It's our choice. What does it make sense to boil down to? Oh, we already have that, because remember, our entire apply expression now boils down to 2 lists. Result, new scope. Well, resulting scope. Might not be new, but... Yeah, so what a lot of programming languages do is defines resolve to their value. So what we might do here is it might boil down to a 3. That would be an unreasonable thing to do. You could, I think you were suggesting maybe it boils down to the variable name, something like that. That's fine. You just have to consider the ramifications of it. Chances are people aren't going to use the 3, but the point is they could. All right, so we can pick our poison, but maybe we say this guy boils down to 3. We'll just do this as a reminder, because that's pretty consistent with modern programming languages. Along with this new, in this case it was a new scope stack that has been expanded. Well, I actually haven't expanded it yet. I'm going to expand it with list Z that also happens to be equal to 3. I just really like storing 3s here. All right, so I've expanded my most local scope with this new variable Z. All right, so that's what has occurred. All right. Then when I go to execute this expression, this guy is going to get executed in the environment that resulted from this guy. So I'm still passing around those environments, but I haven't changed any global variables at this point. I'm just waiting for the result. But now, when this block ends, what if we have a block inside of a block? So what if I have something like block, and then it does all this stuff. That's the end of that block. And then we do something like actually, I'm going to change this slightly. I'm going to define A is 3. So that'll put an A3 there. Keeping in mind that we have an A is 5 over here. So A is 3, and then we'll do plus plus A. So this should boil down to 4. But then let's say we do just A here. That'll be a var expression. This guy, let's even take the plus plus A off. Just keep it simple. So this A is occurring inside of the block where an expanded scope happened. This A is happening back in the old scope, where A here should boil down to A5. That make sense? So we're going to have to, next week, we're going to have to come back, we're going to have to figure out how do we manage this block expression so that scopes can live and die, and we can revert back to an older scope without having some sort of global variable. All right? No homework over break. If you're traveling somewhere, drive safe, travel safe, whatever. And I will see everybody on Monday.